In this microcontroller lab video, we are now going to discuss what is a 7-segment display and how we can use a microcontroller to control the display of a number or a character on this particular 7-segment display. Now we can go to our component list and we can select our Arduino and we can select our 7-segment display, and you can select this digital 7-segment display, and once it is done we can be able to do the connection. We can place our Arduino and we can place our 7-segment display, and we can display, for example, a count of number from 0 to 9 on this 7-segment display. And we have this pin here which is A, B, C, D, E, F and G, and we will now start the connection as per the description of the pins with the Arduino Uno. And now we can begin our connection. We start from 2 to G, and we have 3, 4, 5, 6, 7 and 8 is connected to the A pin of the 7-segment display. And now our circuit is complete, and we want this Arduino to print a countdown of a number from 0 to 9 on this particular 7-segment display, and it is a common cathode display. Now we can open up our Arduino IDE and we can write the code for this particular countdown of this system. Now we have our Arduino IDE open, and we can now be able to look at the circuit diagram and write our code. And firstly, we will start by specifying the variable which is the segment. So we initialize by giving this particular segment an integer value such as the segment, and we specify as 7 byte, and we can be able to specify the pins which is corresponding to the 7-segment display. As I have mentioned, we have A, B, C, D, E, F and G. Those are the pins on the 7-segment display, and it is now connected to each of these pins. And firstly, we can see that we have this which is A, which is connected to pin 8, and we can now specify 8, 7, 6, 5, 4, 3 and 2. And now these are the pins. We can say pins A to G for this particular 7-segment display. Now we will specify the byte number, and when each of these bits will be changing, and then these changes will now make this portion of this particular 7-segment display to light up. And we have this when this pin 8 of this Arduino Uno, which correspond to A pin of this particular 7-segment display is 1, only this top part will be on. And when A and B is I, we should have this and this is on. For example, if we want the 7 to be switched on, that means we have this part and this part. So we have A, B and C must be on, and all of them must be off. So we should have 1, 1 and 1 at this line should be on. So we have pin 8, pin 7 and pin 6 must have a logic 1 in order for us to have a 7 display on this particular 7-segment display. I will further explain on this. However, we can now specify let's say the byte number, and we have the countdown from, let's say, 10, 0 to 9 on this 7 segment display. And now we can specify the bit such that we have 1 1 1 1 1 1, and we have the 0. And now we have A, B, C, D, E, F will be on and G will be off. And in this case, we now can say this is corresponding to the 0. And the next, we should have 0, 1, 1, 0, 0, 0, 0. And for this case, comma, we can say it is now corresponding to the 1. And then we have 1, 1, 0, 1, 1, 0, and 1. And now this byte will be corresponding to 2, and we can have 1, 1, 1, 1, 0, 0, and 1, which should now correspond to 3, and we can have 0, 1, 1, 0, 0, 1, and 1. This now should correspond to 4, and we can have 1, 0, 1, 1, 0, 1, and 1. This should now be corresponding to 5, and we can have 1, 0, 1, 1, 1, 1, and 1. Now this should correspond to 6, and we can have 1, 1, 1, 0, 0, 0, and 0, which should now be corresponding to 7, and we can have 1, 1, 1, 1, 1, 1, and 1. We can now see that it is now corresponding to the number 8, because all of this LED which is inside the 7 segment display will be switched on. And we can now have 1, 1, 1, 1, and 0, and we can have 1, 1. Now this can be correspond to the number 9, and we can have a colon which gives the ending of the byte number. And now under the void setup, we are now going to use a statement known as a for statement. A for statement is mostly used for the counting, which is corresponding to the incrementation or decrementation of a value, such that if we give an integer value and we initialize this integer as a variable I, and this variable I will store the count such that if I is equals to 0, and we give a condition such that I is less than the 7, and we have I plus plus. And what does that mean? This is the initial condition for the for statement, and this I is less than 7 is the condition, and I plus plus is the incrementation. And For this case, we are now counting from 0 to 7 and it will increment such that we are now declare the pin mode for the particular segment that we are going to display, and we give with respect to the variable I. And if I is our output, and in this case the pin mode will now be able to declare such that the segment is nothing but the output pin. When the count begins from I is equals to 0, it will count up to 7 times. When I is equals to 0, it is true. When I is less than 7, that means 0 is less than the 7, where 7 is the final value. And if this condition is true, it will add I plus plus, means I plus 1. In our case, 0 plus 1 will be equals to 1. And in the next cycle, I will be equals to 1. And when 1 is less than 7, it is true. So we will have 1 plus 1, it will be equals to 2. And now, because of this segment, we know that these segments should be S, where the segment is from 8, 7, 6, 5, 4, 3, and 2, which correspond to the pin on this 7 segment display from A to Z. And most 7 segment display use a number system called the binary coded decimal, and which we are using here. And for this byte, we create a form of a matrix where we map the number count between 0 to 9 with the 7 segment display. And we have this 7 segment display corresponding to the pin of the Arduino, which can be high or low. And once it is done, we will go to our main function, which is the void loop. And for this void loop, we are going to also use a for statement, so we can be able to increment the value from 0 count to 9. Therefore, we can now create a for statement. So let's say we give the integer value of the number, which will be the number that we normally going to display. When num is equals to 0, we can have is num is less than the 10, then we can have num plus plus. So this will now be able to show the counting of a number between 0 to 10. That means it will display the value from 0 to 9. And now we can have another for statement, and in this case we can say integer segment, which is equals to 0, and if this is true, we can say if the segment is less than 7, then we can have segment plus plus. And from there we can be able to now write the digital pins, such as the digital write, and we can have segments, and we have the segment that are to be displayed, and it now will be mapped with the numbers. And the numbers, it is now corresponding to the num, which is the cycle in which the for loop will count from 0 to 10, and we can end by using a semicolon. And after this, we can now add a small delay, such as 1000 milliseconds for every 1 second, and the loop will continue. So first it will compare the number. If the number is 0 at the initial state, now if it is true, it will increment the number to 1. And after this, it will now compare the segment, which is the segment that we have corresponding to the pins from 0 to 7. And then from there it will write the segment and the number. When the segment is 0, number is 0, that will be the initial case. And then with a small delay of 1 second after this segment variable will hold 1 and this number will also hold the value of 1 because they are incremented in this code. And after this we are done with our code, so we now can be able to compile and see if there are some errors. So we have the error where it says before the byte. So we have this one is the number and the segment. So the byte number, this should be num, and we should have the segment where it will now corresponding to mapping of the number and the segment. And also this error, it says that we should have a comma or a semicolon at the end or before the byte. So before the byte we have the byte here, so in here we should have a semicolon, and I think our code is okay now, and we can run to see if there are some more errors in our code. And I think our code is okay now. So this is our full code in which we can now be able to print a number from 0 to 9 on this particular 7 segment display. And we can now go to export compile binary, and once it is done we can simply double click and we go to the exa file and we can import. And now since there are no more errors in our code, we can simply run the simulation, and we now have 0, 4, 5, 6, 7, 8, 9, and we have 0 and 1. There is a problem with the 1. So let's check our code again to find where does this error come from. And for our case, for 1, we should have A, B, and C. And in that case, only B and C must be 1. So let's check. So in that case, we have this one is A is supposed to be 0 and B and C must be 1. Only this B and C must be 1, and all of these must be 0. So we can have 0, we can have 0, and we can have 0. In that case, A will be 0, B and C will be 1, and D, E, F, and G, all of them must be 0. Now let us compile our code again. And we go to sketch, we export the compile binary. And now we can run our simulation to see we now have 0, we have now 1, we have 2, we have 3, so now it is okay now. So this is our code, which is corresponding to our countdown of the number that is displayed on the 7 segment display. And I believe with this example and the detailed explanation on how this code can be executed following our instruction given on this program, I believe you should be able to fully understand how we can be able to display any characters or a number on this particular 7 segment display, because it is important in your future application. If you want to display some numbers or a character on this particular 7 segment display, you should be able to know how those numbers and the pins are corresponding to each other. So in that case, you should be able to fully program and execute your code so this 7 segment can be fully functional to display whatever character or the number you wish. So I believe you can be able to share this video and like our video and click the notification button so whenever we upload our new video, you can have access to it at that instant. Thank you for watching our video.